Hey guys, today we are going to learn about compound inequalities. What is a compound inequality, you might ask yourself? Well, a compound inequality means that we are just going to be solving more than one inequality at the same time. There are two different types of compound inequalities. One of them is the AND inequality, and the other one is an OR. What do they look like? Imagine this is you. How does your height compare to that of an ant and a skyscraper? Well, your height would be both taller than the ant and shorter than the skyscraper. So here's you in between the ant and the skyscraper. And oh look, here are our arrows that are pointing to where you are at. This is an example of an AND inequality, which you heard me use in the sentence. AND inequalities involve two arrows that shade toward each other. Here's you again, and let's say that you like to watch the stars. This would be the sunrise. This would be the sunset. There are only 2 times during the day which you can watch the stars. You can watch for stars either before the sunrise or you could watch for them after the sunset, but you cannot watch them in the middle of the day because you can only watch them at either one time or the other. This is an OR, and our times are opposite each other. So for OR inequalities, we have 2 arrows that go in opposite directions. Okay, first example, 3n minus 3 is greater than or equal to 6, and 7 minus 3n is greater than or equal to 1. We have to end up solving both. So I'm going to start with the one on the left first. It's a 2-step inequality. I will add 3 to both sides to get rid of the minus 3. That's gone. 3n is by itself. Symbol stays the same, and negative 6 plus 3 is negative 3. To get rid of the 3 touching the n, we will divide on both sides by 3. Those cross out. Now n is greater than or equal to negative 1. We do not have to do a flip because we divided by a positive number on both sides. Second inequality, I'm going to start by getting rid of the 7 by subtracting on both sides because this is a positive 7. The 7's cross out, so we're left with negative 3n is greater than or equal to... Ooh, I have boo-boo there. Quick fix, this is a positive 1. 1 minus 7 is... negative 6. To get rid of the negative 3 touching the n, we will divide on both sides by negative 3. The negative 3's cross out, so I am left with n. And we're going to have to end up doing a flip because we divided by a negative number. So that changes direction, and negative 6 divided by negative 3 is positive 2. Alright, graphing time. So when I graph, I'm going to have a closed circle on both ends. There will be a closed circle at negative 1, a closed circle at 2, and then I will just end up shading the space in between them. Okay, negative 10 is less than 6n plus 8 is less than or equal to 38. Believe it or not, this is actually also an AND inequality. It doesn't look like it because the word AND is not there. But when we break it down and end up solving it, it will turn out to be an AND inequality. So here's our first inequality. I'm going to write it over here on the side. Negative 10 symbol, 6n plus 8. And to get our second inequality, we're just going to reuse the stuff in the middle. And then everything over on the right side. So I'll have 6n plus 8 is less than or equal to 38. Well, the nice thing about this one is because we have the same chunk in both, we can kind of do both at the same time. So I'm going to add 8, pardon me, I'm going to subtract 8 from both sides. May as well just get both done in one go. The 8's will cross out. In the left inequality, negative 10 minus 8 is negative 18. Symbol stays the same, and I'm going to keep the 6n. In the right inequality, I'm still keeping the 6n, keeping the symbol, and 38 minus 8 is 30. Now I have to divide by 6 for both. The 6's cross out. Negative 18 divided by negative 6 is negative 3. No flip is required because we did not divide by a negative number on both sides. N stays the same. Same thing over for the right inequality. N stays the same. Symbol stays the same, and 30 divided by 6 is 5. Okay. We have one less thing to worry about because this is backwards. So I'm going to swap it. The n and the negative 3 change places, and the symbol changes direction. So now I am ready to graph. I will have an open circle at negative 3, a closed circle at positive 5, and because of the directions that the arrows are pointing, we will shade the space in between. And oh look, this one actually does end up being an and inequality as promised. It just didn't look like it as at the beginning because we had this overlap which we had to split into two pieces. Okay, last example. Negative 4 plus 5x is less than or equal to negative 19, and 4x minus 2 is greater than 6. So I'm going to start by getting rid of the negative 4 by adding 4 on both sides. They cross out. 5x is by itself. Symbol stays the same. Negative 19 plus 4 is negative 15. To get rid of the 5, we will divide. 5's are gone. X is by itself, symbol stays the same, and negative 5 divided by 5 is negative 3. We don't have to do a flip because we divided by a negative number on both sides. Right side, we're going to add 2 to both sides to get rid of the 2. 4x comes down, symbol stays the same, 6 plus 2 is 8. To get rid of the 4, we'll divide by 4 on both sides. X is now by itself, symbol stays the same, and 8 divided by 4 is 2. Okay, when we graph these, we're going to have an open circle at negative 3, a closed circle at negative 3, an open circle at positive 2, and if I use the trick to shade the direction the arrow points, that means I'll have a shade to the right and a shade to the left. And they should not be because this is an OR inequality. Thanks for watching.